Functioning of lens in human beings. Activity. Photographic cameras are nowadays a household appliance. You must have used a camera when you had been on a picnic to a memorable place. Have you thought about how a camera works? A convex lens is used in the camera to produce image on the photographic film. A control is provided to focus near or far object. Camera is used to photograph objects in different conditions. When light is bright, the aperture of the camera is reduced to reduce light falling on the photographic film, and if light is less, the size of the aperture is enlarged to gather more light coming from the object. Do you know our eye is similar to a camera? Our eye also has a convex lens which produces an image on the retina. We can also focus near and far objects. When it is bright light, we narrow our eyes to reduce the light, and when it is dark, we spread our eyes. But there are some differences also. Can you guess what are these? Well, the camera has a single lens while we have two lenses. It is because of the two eyes that we see depth. That is, we see a three-dimensional picture while the camera sees a two-dimensional picture. Human eye. Human eye is a remarkable optical instrument designed by nature. It is like a camera. It is the eye which makes it possible for us to have the knowledge of beautiful and colorful world around us. It is one of the most valuable and delicate sense organs. Let us study the structure and working of our eye. The eye is very nearly spherical in shape and is about 2.5 centimeter in diameter. There is a thin membrane on the eye called cornea. The cornea is the transparent spherical structure at the exposed surface of the eyeball. It is the portion which is bulging outwards. Light enters the eye through the cornea. The region behind the cornea is filled with watery fluid called aqueous humor. Cornea and the aqueous humor together refract most of the light entering the eye. Behind the cornea, there is a dark muscular diaphragm called iris. It is the colored part of the eye. You might have seen different people having different colored eyes. It is the color of the iris which is different for different people. There is a small opening of variable diameter at the center of the iris called the pupil. It is the pupil, controlled by the iris, that regulates the quantity of the light entering the eye. When the light is very bright, the muscles of the iris stretch over the pupil to reduce its size. When the light is dim, the muscles of the iris relax to increase the size of the pupil. Thus, the iris controls the size of the pupil and hence regulates the quantity of light entering the eye. The tendency of pupil to adjust the opening for light is known as adaptation. There is a crystalline, transparent and biconvex lens behind the pupil. The eye lens is composed of a fibrous jelly-like material. The lens forms a real and inverted image of an object. The lens provides fine adjustment of focal length to focus image on the inner surface of the eye. This is called the retina. The retina is a delicate membrane. It consists of large number of light-sensitive cells connected to optic nerves. These cells produce electric signals when they are illuminated. These signals are taken to the brain through optic nerves. The brain interprets these signals and processes the information contained, and image of the object is perceived. A point where the optic nerve enters the eye is called the blind spot. Image formed at this point cannot be seen. Majority of the portion of the eye, that is, the region behind the lens and in front of the retina, is filled with liquid-like material, mostly water, called the vitreous humor. Now let us understand how our eye adjusts itself to see objects at different distances. The focal length of the eye lens can be changed by contracting or relaxing the ciliary muscles. The eye lens in relaxed position of eye muscles has a focal length of about 2.3 centimeter. In this situation, the lens is thin. Thus, the focal point of the eye lens is located on the retina. Hence, a normal eye in its relaxed position can form sharp images of objects located at infinite distances. When we are looking at objects closer to the eye, the ciliary muscles contract. This increases the curvature of the lens and the lens becomes thicker. Consequently, the focal length of the eye lens is decreased. When we are looking at a distant object, the ciliary muscles are relaxed so that the lens becomes thin and its focal length increases. This enables us to see distant objects clearly. The ability of the eye lens to adjust its focal length is known as power of accommodation. The process of focusing the eye on different objects placed at different distances is called accommodation. There is, however, a limit to the smallest value that can be attained by the focal length. Because the ciliary muscles cannot increase the curvature of the lens indefinitely. Thus, the focal length of the eye lens cannot be reduced below a certain value. If objects are placed closer to the eye than this distance, they cannot be observed clearly. For a normal eye, the minimum distance from the eye at which the objects can be clearly and distinctly seen without any strain on the eye is about 25 centimeter. This distance is known as the distance of distinct vision.